Hi everyone, today we are starting activity 8 with lesson 8.1, which is going to talk about composition of two functions, and eventually we are going to in lesson 8.2 determine the inverse of the function. So I don't really love our book's notes here, so what we're going to do is we're going to do those in class together, but instead I have this handout that I should have hopefully attached to the Edpuzzle video link in Google Classroom so that you guys can follow along here. Basically, what are a composition of functions? Well, a composition of function is where one function is inside another function. So, for instance, given h of x here, we could say that the function h of x is actually the composition of two other functions, the inside function and the outside function. So, for instance, we could say that the inside function is 2x minus 1 that we plugged inside of z squared. And we could have used any letter besides z. Z was just a variable, the one we wanted. And so we basically plugged the 2x minus 1 into the variable z. So we ended up getting our composition of 2x minus 1 quantity squared to form our new composition, right? Now, generally, you'll see the notation like so, either the f of g of x or represented as like so, f of g of x. I usually prefer this notation because it shows me I'm plugging in g of x to my f function, but you'll also see it this way as well. They're equivalent to each other. What's not equivalent, however, is f of g of x and g of f of x, right? These two are backwards from each other. They're not necessarily going to be the same value, and if they are, that's where the whole inverse idea comes into, because they both would simplify to be x. So f of g of x, again, could be represented like this. G of f of x would be represented like this. And f of x and g of x tend to be the two functions we use the most, but you also will see h of x. You'll see other functions represented as well. These are just kind of the two most common composition forms you'll see. Okay, so let's see. Now, we always want to pay close attention then to how they're written, because again, the order is not commutative necessarily. Now, our domain also is important here before we get to the yellow box, because whatever the domain is, for instance, of f of g of x, your input function, well, the output value of that function, aka the range of it, is what the only input values we can have for the outer function. Thus, the range that comes out of that is our total range of the function. So the domain of your inner function is going to be the domain of the composition. The range of your outer function is the overall range then of the composition. Not a huge point, but it does help us narrow down sometimes potential domains if necessary. Okay. Now, back to the yellow box that I kind of skipped over. When we write this, we've done compositions sometimes already when we talked about inverses with logs and exponentials, but you're going to plug the inner function into all the variable features of the outer function and simplify as much as possible. So if we flip to the next page, we have a couple examples given to us. So the first one wants us to find g of h of x. Basically what that is telling us is that our function g is the outer function, and we're going to input h of x as the inner function. So g of x is 2x squared. So anywhere we see an x, we're basically inputting 3x minus 5, our inner function. And again, this is squared minus 7. And again, here's another x. So we're going to type in, or write in, 3x minus 5. Okay. Now from here, we need to simplify. So 3x minus 5 quantity squared, this guy here. Again, that's the same as saying 3x minus 5 times 3x minus 5. So we need to expand this into being 9x squared minus 15x minus 15x plus 25. And then we still have the minus 7 times 3x minus 5. So we could distribute that. We end up with negative 21x plus 35. And then we still officially have this 2 out front here. So we end up, if we simplify here, we distribute the 2 to each piece here. We end up with 18x squared. And then these two together, we had negative 30x. So if we double that, we end up with negative 60x and then plus 50. And then still have the minus 21x plus 35. And if we combine one more time, that should be all we need. We have 18x squared and then negative 60x minus 21 more x's minus 81x. And then 50 plus 35 is 85. Okay. And our domain here should end up being all real numbers because nothing is going to end up messing this up in case they were asking you for domain at all. All right, now example 2 involves a square root, and this time we want g of f of x, aka our outer function is g of x, and we're going to input f of x for all the x values in g. So g, and then we have x, so we're going to input for x 2x minus 5, and then x was squared in g of x, minus 3. Now, this one's a little bit easier when it comes to simplifying because anytime you have a square root squared, they cancel out. So we're just left with 5 times 2x minus 5 minus 3. And if we distribute that 5, we end up with 10x minus 25 minus 3, which is just 10x minus 28. All right, last but not least, and again, domain here, we're good with all reals there. Just be careful that some of what might have caused your input value, though, some restrictions. So just because this output value, you sometimes need to be careful of this. But right now, we are going to move on to, again, we'll focus more on domain in class, but right here for example 3, we want to be careful. Again, we have h of f of x. So h of x is our outer function, f of x is the inner function. And f of x has this piece here, and then our x value, we're going to substitute in the x value here is 2x minus 1. Now, here, what we want to start doing when it comes to the simplification process, I'm going to change that x to the negative first to be 1 over x. So this is currently our denominator, okay? Now I'm going to kind of ignore the numerator for a second, and I'm going to focus on this denominator because what I need to do is to be able to simplify this, I need a common denominator in my denominator, which sounds kind of funny. And that common denominator is actually going to be 2 over x, right? That denominator is going to be x. So what we're going to do is we're going to change the 3 to be 3x over x, because now we have a common denominator that will allow us to write this as one value, which is 2 plus 2 plus 3x all over x. And now we have this division of a fraction within a fraction. So what we can do is take our numerator and multiply it by the reciprocal of that denominator. And it ends up being 5x over 2 plus 3x, or 3x plus 2. And this is honestly as simplified as this is going to get on this particular one. Now, notice you have a couple things you're going to want to make sure. You're going to want to make sure for the domain on this one, again, you take into consideration any value that would make your denominator here equal to 0, and also take into consideration any values that would have made that initial input value equal to 0, which in this case, again, is nothing here. We're going to have to worry about as much. So we're only going to have to worry about for domain here, the denominator of this fraction, okay? We will, again, work more with some contextual situation stuff in class. and talk a little bit more again with practice with composing as well as looking at some of those domains. Okay? Thanks, everybody.